Okay, so now we're ready to start calculating our last part of the assignment, which is identifying the rates of growth. So this is the speed of the growth and the acceleration of the growth. Now you can see I've typed up all of my equations over here just to make it a little bit neater. And in your assignment, you should be typing stuff up. Remember, Alt+ gets the equation editor up. So I've set up some tables just by saying the domains of each of the functions. I've stated what the function was. I said what the actual subscriber gain per month was and what the predicted one is going to be from our equations that we've determined. I've also done the predicted speed of increase given by our equations and the predicted acceleration. So all I need to do is put in equals. And now I'm going to type this function into Excel. So remember to use brackets carefully. Excel is not overly nice to use. I'm sure you could do this with another program if you really wanted to. But, you know, I find that Excel is the most useful for you guys later on, so I'm committing to it. Okay, for multiply, I press shift and then that little star, and then I'm going to select this cell over here so that I can just drag it down. The whole point of Excel is that we want to work smarter, not harder. So by being able to drag code down, that's going to save me a lot of time, a lot less input in my calculator. This is also how you're going to get your marks to show that you can use technology effectively. So make sure that you are getting that code in there because we're going to ask you to display it later and attach it as an appendix. Okay, so +140,812, enter. Okay, now I've got that. Now I'm just going to click on it, put a little plus in the corner there, and drag it down. Now I've got what my predicted one should be. Okay, next we're going to do the predicted speed just by pressing equals. Then we're going to, well, for this one, it's just going to be the same thing the whole way across because it gives us a constant value. So 205,600 divided by 3, enter. Now I'm going to click on that one, drag it down. Last one's just all going to be 0. Click on it, drag it down. If you chose to not do a linear model, if you've done some other form of polynomial, then obviously you would end up with numbers in here and numbers in here. So what this is showing us at the moment is we have constant acceleration for the channel and the speed of its increase each time. So each month, it is gaining the same amount of subscribers. So it's got a constant speed. Now we're going to go down and do the exponential model. So here we're going to put equals, enter in our first set of code. Now to get an exponential, I want to click this one here. So see how it comes up with the side and it tells you what it is. Returns e raised to the power of a given number. I'm going to click that one. Expo. Keep typing in your functions. 2. Now I'm going to type in ln. And down here I can see that one returns the natural logarithm of a number. So I want to use that one. Okay, so 123 divided by 552. Close bracket. Plus 1/3 ln, we want to use our code again, 299123 divided by 552, and now that is multiplying this value, oops, sorry, not that one we don't want it to be A2, we want it to be A10, so A10. All right, and now I can close that bracket there, press enter. If it doesn't like something, it's going to show you by doing that, and it'll go back to where it is. So it doesn't like that it's missing the multiply at the front there, so I'm going to add that back in. It's corrected something, but now I've got a predicted number from that. So something has obviously gone wrong because these numbers are nowhere near where they should be. I'm going to quickly go back to Desmos just to double check and verify that that is correct. So if I go to Desmos, I should be able to go down here to my predicted line and click along that predicted line. So for our function there, 0 should start at 1.408 times 10 to the power of 5. And this function is going to end at 6, should be 7.554 times 10 to the power of 4. So let's just quickly go and double check that those answers are correct. Nope, something's gone wrong in our code. So we're going to click up here and we're going to look for where that error is. Wait, I'm checking the wrong function. For an exponential model, that totally makes sense because exponentials have freakishly large values. So we're still going to verify that that is correct. So up here at 9, it gives us 2.99 times 10 to the power of 7, the actual value. So let's double check that one. At 9, no, it's not giving us anywhere near the right one. So we're going to double check our code. 55200 times e to the power of, I'm missing the -2 times ln. Okay, that is probably our mistake. Nope. Try again. So -2 ln. That number is correct in the bracket there. Now it's got ln2 there. Let's get rid of that. And let's get rid of this little bracket here, that little time symbol there. Okay. Okay, that looks a lot better. So you see, when you get a funny answer, don't just give up. Go back and try again. So now I've got the correct code. Now to save myself some time of entering this, I'm going to copy that code. And I'm going to go over here, control and paste it. Now we already determined that the bracket's not going to change. So I'm going to leave that part alone. And in the front here, I'm going to do a multiply symbol. And I'm going to add in the part that is going to be included there. So this 1/3 part here. Control C, go back to the front here, Control V. There we go. So now that should be the correct answer. So it's still drawing from that same cell. Grab that there, pull it down. Okay, now I'm going to copy this code again. Control C. Next thing I'm going to do, click here, select equals. Now I'm going to, this part here, I'm just going to raise it to the power of 2 because that part gets squared when we calculate the next derivative. So put another bracket around it so it's squaring that whole portion at the front there. That's the only thing that'll change in this equation when we calculate the acceleration. Press enter, and there we go. Now I'm going to drag that part down, and we've got our accelerations. Now, it totally makes sense for an exponential function for these to have huge values for the acceleration because that's what an exponential function does. It increases rapidly as it gets larger or smaller. All right, so next thing we're going to do, trig functions. Now, from memory, sometimes funny things happen when you enter your trig functions into Excel. So remember that you can always just Google what you want. So we're going to go across. I'm going to press equals. I'm going to enter in that first function. See if we can copy and paste this. Some of it came across, not bad. Okay, so we want that to be pi, the number. So I've got to type it in like that, double click it. I want this to multiply like that. So it's pi on 22 times the bracket. Okay, and then now we need to select our sine function. So we want this to be our sine function, and it'll probably want us to put a multiply symbol in between those two, just like that. Okay, so now we're going to replace that t with where we want it to draw from. So we want that to be this cell here. Press enter. Now it's given us that. So we're going to quickly go back. Nope. I'm going to stop this video here and then we'll pick up where we leave off after I have a little research.